How's audio? We're good? All right. Well, that was the smoothest setup yet. Well done, team. Rainy day today, but we've still got a lot of people here, which is fantastic. Good to see you all. How is the first 2 weeks gone for you all? Good? Good? We finding it's been a smooth start? No. Well, it's only going to get worse. What was that? Okay. All right. Is someone playing the video or is it you guys? Oh, okay. Tim's going to turn that off because that will kill me. I can hear a weird echo. All right. So let's do a brief recap of the last few lectures. This is typically how I like to start. It is brief, so it's, don't try and follow along too long, but I just want to re-jog everyone's memory and set a bit of context. So we've talked about control flow, which is the top level concept for changing the way our programs run. So part of control flow is conditions, so true or false conditions, if statements and else if statements and else statements. Someone want to yell out what if and else if statements are useful for? Control flow, someone said. Yeah, checking some true or false statement and deciding what to do based off the result of that. Then we looked at while loops at the end of Monday's lecture, which are quite similar to if statements really, except what's the major difference? There's repetition. So if the condition is true, you run the block. And then for an if statement, that would be it. And for a while statement or a while loop, you go back and check the condition again, and you just keep repeating that until the condition is false. So that's the mechanism that allows us to do things over and over and over, which is obviously really useful. And we also looked at scanning, so reading values from the terminal. All right, today we're going to look at 2 things. Nested loops, which is sort of just an extension of while loops. So it's not actually a new concept, it's just a new way to use loops. And then a big new concept, which is custom data types. A really important concept. I mean, you'll use all of these concepts for the rest of the course, but custom data types, really, really important. All right. As usual, any of the lecture code I write is available at this link. Obviously, you can just substitute week 2 for the week that we're up to. So you don't have to type this all out. Where do you go if you just want to grab this link? The home page, yeah. Go to the course page, click live code, and you'll get directed. All right. Let's do a recap look at if statements. So here's the syntax for an if statement. We have the if keyword, which is a special sequence in C, right? This if. Which says, okay, now I know that we're going to have an if statement here. And then we have the condition. And the condition, when I put these angle brackets in my syntax code, that's the placeholder, right? So that's the placeholder for the condition that we need to have in whatever if statement we want. So the condition can be lots of things, but what does it always boil down to? A true or false value. No matter what crazy thing you ever see in that condition of an if statement, you should know it's always going to end up being a true or false, or sometimes in C, a 1 or a 0. Always. That's actually not true. If it's a 0, it's false. If it's 1 or anything else, it's true. Is that right? Or is it the other way around? That's right. Yeah. But it will always be interpreted as a true or false value. So if it's raining, bring your umbrella. You say, whoops. Yeah, I did bring mine today. I was very organized. The next important part of these if statements, syntax, are these blocks of code. We've spoken about blocks of code before when we had the main function, right? These curly braces, the blocks tell us what is associated with something. So in this case, these are the lines of code associated with the true branch of the condition. Did that make sense to everyone? If that condition is true, everything in those squiggly braces will run. It's how we organize and group code. Then we have this else if. So we already know how if works, right? We just ran through that. The else, if it's before an if statement, means that it must follow another if statement. And it only checks this if statement if this was what? False. Yeah, it's the else case. And in this example, we have an else without an if, which only runs if this was false.
Can else if be abbreviated to elif?
No, you can't abbreviate else if in C. You've probably done some Python, I'm guessing, or something like that. That's it. That's if statements. They will look more complex in the future. You might have more branches. You'll have more complex conditions. But that is the basic building blocks. Here's a few more facts for you if you just want to jot them down. We've already said this. Conditions have to be true or false. We execute an expression to calculate a condition. So it's not like we always have, true or false in there. It could be, is some number greater than some other value? Is it raining or whatever? So we can execute an expression to return back a true or false value. So there's that example from Monday. If my age is greater than the drinking age, if that's true, that will boil down to a 1, which is a true value. And then we'll do the true branch. Yep. Is this getting repetitive? We're all comfortable? And then let's talk about repetition. Okay, while loops, exact same way to interpret the syntax. While some Boolean condition. So if some condition is true, run the block, except we go back and check the condition again at the end. And eventually the idea is that condition may be false, at which point you continue on with your program. So while loops is one point, maybe the first point so far, in which we can get into a little bit of trouble with our programs. What could the problem be with while loops?
The program never ends.
Yeah, if the condition never has the ability to evaluate to false, there's a chance you will do what's called halting. So your program will just never end, right? If you had while true, it'll never end. And you will have to manually intervene, or your operating system will have to manually intervene and kill your program.
Does our program automatically intervene, or do we have to?
No, it will not. It'll run forever. Yep. So the question, I'll repeat the questions because the online students can't hear sometimes. The question was like, will it automatically stop at some point? The answer is no. Someone would have to intervene. Maybe your laptop would run out of battery or something. Okay, so that's the recap. Any questions? Nope. Alrighty. So today's first topic, nested loops. Like I said, nested loops aren't a new concept. So there's concepts and there's applications in code. Applications is when we use the concepts to do things. So this is not a new concept, it's just a new way of doing things. And it is so simply having a while loop within a while loop. It's that simple. But there's a lot of powerful things we can do with this idea. And so it means that every time the outer loop runs, the first loop, the inner loop runs its entire loop. So let's have a look at an example of why these are useful. So here's some terminal output that we want to recreate. All right, so I want you guys to print out exactly this. So it's a 2x2 grid of 5 values, 1, 2, 3, 4, 5, and it's repeated 5 times. How would you print this right now, maybe without nested loops? Someone said printf where? Yeah, what would you do?
1, 2, 3, 4, 5, and then repeat that sentence.
Exactly. So we would do something like, let's just pretend I've got a main function here and all this stuff. Let me just gently move this out of the way. We could do printf, 1, 2, 3, 4, 5 with a new line. And I would have to repeat that 5 times. Does that look good to everyone? Something like that is what you would do. But I did say, remember I said something on Monday about repetitive code? Anyone remember what I said?
Programmers are lazy and they don't like to.
Yeah. And I also said that if you see something like this, if you see repeated code in a program, what did I call the term? Anyone remember? Sludge. Code smell, I think I called it. Although I like sludge, code sludge. It's a bad sign. It's a bad sign. It's not neat. It's not elegant. So the idea is there's a better way to do this. Again, 5 examples isn't a lot, but what if you wanted a 50 by 50 grid? Do we really want 50 lines of code clogging up our program? What if it was 1,000,000? We don't want a 1,000,000-line program that just prints a few numbers to the terminal. So if we think about it, we don't even need to print 1, 2, 3, 4, 5 like this. So let me quickly set up a program here, actually. Just move this over. Okay. Well, why don't we just run this for the sake of it? DCC, it's called nested loops.c-out to program. And I'm going to run program. So there we get our nice little grid. So we can call this version 1. Sludge. All right. Even the 1, 2, 3, 4, 5 is repetitive within a single line. What else could we do there instead of printing it manually? Use a loop. So this is just counting by 1. 1, 2, 3, 4, 5. So what could we do instead? that a hand? Yes. What type would the variable be? An int. Why an int? You're right. Let's create a number to represent each of those values. Or in fact, it should start at 1, shouldn't it? Because it starts at 1 here. In fact, let's start at a 0. Okay. Let's create a variable that's going to represent 1, 2, 3, 4, 5. And let's use a loop to add 1 each time and print it out. So how do I write a loop? While. All right, now we need the condition. So when should this loop run? Who's talking?
I is less than 6.
Let's do I is less than 6. Let's do that and see how it goes. So while I is less than 6, and what does I start off as? 0, okay. So while I is less than 6, let's run this body. And what are we going to do in the body? Yep. No, I'm just printing a single line. I just want to print a single line. Yeah, that's good.
Outside the quotes, comma, I, space I.
Wait, who said that? That's excellent. What did you say? I plus 1. Why? Because it's 0, but I want it to start at 1. Yeah, exactly. This is quite common to do. It's good convention to start our counting at 0 if we can. And even though I want it to start at 1, I'll just add 1 when I print it out. Rather than starting at 1. Right, do we see that? Okay, so that was a great catch. What were you going to continue saying?
Semicolon.
All right, we'll see how this goes. There's a few little tiny problems with it, but this is a decent start. If I ran this, what would the problem be? Would the loop ever end? Why not? We're not changing I. We're only printing it. It's always at 0. So I can do I is equal to I plus 1. All right, so now every time the loop runs, I will go up by 1, but we'll print out the value of I plus 1. I'm also going to do printf just to show you. So I'm going to do right, just so we can sort of see separately. So version 1 printed what we knew. Version 2 prints 1, 2, 3, 4, 5, 6. So we're off by 1, and there's another little issue in which there's no spaces between the numbers getting printed. But we're kind of close. Like we've almost printed out a full line. So how do we fix these two little issues?
Change the condition to be I is I.
Yeah.
And then also put the space on the.
Exactly right. Very good. Let's leave it at that for now. So we were looping 1 too many times. We saw that because we printed 1 too many. We can also think about that because you've got to remember I starts at 0. So 0, 1, 2, 3, 4. 5 is when it fails because 5 is not less than 5. So that would be 5 times. All right. Let's run that. 1, 2, 3, 4, 5. That's looking really good. We've printed a full line that matches what we wanted to print. And again, it's not too many lines fewer than the previous example, but if we were to think about what if we wanted a 50 by 50 grid, what do I need to change to go to 50? So let's answer the question. Well, yeah, I just need to change this to 50. I mean, it doesn't fit, but you get the idea, right? Let's change it back. All right. Let me continue on before asking questions because I want to just solidify this in a nice example because we're close. We're really close here. We've printed a full line, but we're not quite done because we want to do that 5 times, right? So what can we do? Do I copy and paste this whole thing 5 times? Would that work though? Yeah, but it's kind of an interesting idea. There'll be a little issue with it. Can anyone foresee the issue? Yeah, there's no new line. Did I not? I did save it. Did I not compile it? Oh my, yeah, I didn't copy, sorry, I didn't copy the first line. 5 was staying at, yeah, good catch. I need to fix this formatting. Why can't I format the code as well? What's going wrong with that? Anyway, this will work. Oh, I can't recreate it. There we go. It's printing it all out, but it's missing a new line, so I'd have to add a new line in between each one. But let's not do that for now. Let's just go back to our single loop. All right. So we can do this multiple times by copying and pasting, but we know that's never the solution. There's got to be a better way. And the better way is nested loops. Well, why don't we just do this in a loop? Remember, whenever you've got multiple lines of duplicated code, you can fold it into a loop. We have multiple blocks of duplicated code. Let's fold it into a loop. So this whole thing is going to be folded into a loop. So how do we do this? Anyone got any ideas for where I start?
Well, first I'll probably add a new line outside of this while loop, just to make sure we're looping the new line over and over again.
That's great. Yeah, that's fantastic.
And then,
so can we just explain this first? There needs to be strings here. So the idea here is that once we've printed a full line, 1, 2, 3, 4, 5, I need a new line at the end. So once the loop ends, I want a new line. So that when I'm ready for my next line, I'm on the next line. All right, so that's a great addition. Where's my whiteboard marker? Hello? Thank you. So far we've got the code that's going to print 1, 2, 3, 4, 5, and then a new line, right, which pushes us back over here. And we want to do this all again. What do I need? How many times do I want to do this? 5 times. What do I need if I'm going to repeat code? I need a while loop. What else do I need as part of a while loop? A new variable, a new counter. I need to keep track of how many times we've done this. In this example so far on the screen, what's our variable? Can I use I again? No, because it's keeping track of this. So what would I need a new variable. So we'll say I. That's clever. Typically what I said we use I for counting like this. We actually use J as the convention. So I did hear someone say it. All right. So we create the loop here, we loop here. While I is less than 5, we print the line. I think the best way to do it is to wrap it in here. So yeah, I'll explain in a second why I'm going in and doing the inner part first. So in the body of this loop, what are we going to do? We're going to set up a new loop. So I need a new counter. I'm going to call it J. And then what am I going to assign it? 0, because we want to start at the beginning. Now I need to run the inner loop. We know we want it to run it 5 times as well. So I'm just going to use the exact same syntax there. While J is less than 5, run some body. Now what goes in here? The old body, exactly. If we think about it, printing the actual integer d, %d, I, this needs to happen 25 times. So it has to be the innermost thing. Because it happens the outer loop times multiplied by the inner loop times. So this body is going to come in here. Except there's a bit of a problem now. Can anyone spot it? Forget the new line. There's a bigger problem. Who was that?
We need to make it j equals j plus 1.
What? Yeah, we need to print J instead of I. What is I? Did you guys get that? Good. That's cool. So I is keeping track of how many rows are printed. And J is keeping track of the columns now. So J is what we want to print. All right. What else is missing now?
Now there's nothing to keep track of I.
No, well, I is there. It's just not incrementing. Right? We're not adding one to I anymore. So where should we do that? Should we do it in here? What line number? Yeah. Once we finish printing an entire row, right? This represents printing an entire row. Let's actually comment that. Once we finish printing an entire row, then I need to add 1, so I'm down the next column and start again. Yeah, this is only going to print a \n when both loops finish, which is too late. So where should it be? Yeah, exactly. Outside. Oh, it didn't copy. Here. Should we run this and see what it does? Who said that? Why did you think it would crash? You just had no faith, I guess. That's fine. There you go. That's it. We get our 5x5 grid here. Now, there's a few things I would do to clean this code up. But by and large, that is how we do it. So who's got their head around the concept? Awesome. Who's like, I'm completely lost? Fair enough. I mean, I can see that it can be maybe tricky to get your head around. Like there's a bit more going on now, right, in this program. All right, we can do other really cool stuff with nested loops. How do we print something like a half pyramid? Was that a hand? Ooh. So let me do this. Let me copy this and make a new file. And let me delete that. All right, so the thing we want to print now is, well, what was it? It was like 1, 1, 2, 1, 2, 3. You get the idea. It's actually a very small change. I think you're right. In this example, we both start rows and columns at 0 and add 5 each time. So while I is less than 5, while j is less than 5. So if we remember, this prints the columns. This prints a row. When we're printing a row, that's what we need to change, right? Because we're still going to print we're printing 5 rows. When we're printing the columns, that's what needs to change. It is this one. This prints the row. So this what I've selected here is what makes us print 1, 2, 3, 4, 5, right? Do we all agree? Yep. So we want to change this 5. In the first example, what do we want it to be? The first line. Don't give me the answer. Just tell me how many times should we iterate on this line? 3. So we need some variable that is going 1, 2, 3, and we happen to have that. That is I. Oops, wrong file. Well, we're off by 1, I think. So I plus 1. Because I starts at 0. Yep, that's exactly right. And we get a half pyramid. So we can do lots of cool stuff. Anytime you have a grid structure in a program, you usually have something like this. Think of a chessboard. That's a grid. You have columns and rows. And that's nested loops. That's it. That's the topic for now. So you will use that construct quite a bit, especially in assignment 1, I think. We're starting to get to a point, I think we can all agree, where the code is not so straightforward now. You can't glance at this necessarily and know automatically what it's doing, right? Or maybe you can, but most of you probably can't. So it's important that you now learn techniques to slow down, read it, and understand what it's doing. Run the program, see what it does. And the number one thing I do when I'm trying to understand this, I'm going to talk about this a lot this term, is get a pen and piece of paper and draw little boxes for all of the variables and keep track of them and see what it's actually doing. You cannot look at this code and automatically distill that it's printing a pyramid. That would be pretty unlikely, or you'd need a lot of experience in seeing these types of programs. All right. So new topic now. Let's shake our shoulders off a bit. Custom data types. So someone remind me what a data type is? What did you say? That's, yeah, so you said char. That is an example of a data type. What is a data type? The way we store variables. Don't know. Anyone else have an answer? Yeah, that's nice. It's the kind of variable that we store. Another way of saying it is that I mean, type is the perfect name for it. It's the type of value that we're storing. It tells us how many zeros and ones and in what combination and what order represent a certain type of value. And all of the data types we've used so far, ints, chars, doubles, booleans, that sort of don't exist in C, are built-in data types. They're so useful that they come with the language, right? Pretty much every program needs to deal with numbers, characters, things like that. So the language ships with the data types. But not everything that we do can be done with such simple basic data types. And so we need an ability to create our own types of data. And there's multiple ways to do this. The first that we're going to look at is something like this. It's about grouping these data types. This is also sometimes called modeling. So here's a little program with 3 variables, an int, a char, and another int. But these are all related. What do we mean by related? They fall in the same category. What do you mean by category?
They're like distinguished, isolated category, and everything else. They're all integers.
Someone said they're all integers, which they sort of are, but character's not an integer, but that's not the point I'm getting to. Don't look at the type, look at the values. Well, I didn't go to study at UNSW, so no.
Is it in the law code that all just expressed as zeros and ones?
All memory is expressed as zeros and ones. That's true. What I'm trying to get at here is that they all represent a student. They're related. They're not 3 separate variables that have nothing to do with each other. They're 3 pieces of information to do with one entity. Do we see that? They're related. It's their age, it's the user's age, it's the student's initial, and it's the student's year number at UNSW. The problem is, think about your real student record at UNSW. How much data do you think we have about you? Too much? Think about Google. I mean, let's not think about that actually. Let's think about UNSW. We do have your, I can't access, well actually probably can, but your address, your postcode. If you came from another university, we have that university's transcript. We have your transcript here. We have, lots and lots of information. We can't have 50 variables in a program. That's just one student. There's 60-something thousand students here. That would be 60,000 multiplied by, that would be so many separate variable lines of code. That's a nightmare. That won't do. That won't do. We need a way to group similar information into a single thing, a single variable. Is that idea making sense? Yeah. So we want a way to define a data type, some sort of structure that stores a collection of different types of different values. And so we now meet a new friend called the struct. Struct standing for? So if only there was some way we could define a structure to represent a UNSW student. Oh, look, there is. This is the syntax for creating this UNSW student struct. So we use the keyword struct is the first thing, which says, hey, Mr. C compiler or Mrs. C compiler, I want to define a new struct. What's the name of the struct? I want it to be called, in this case, UNSW student. So I'm creating a new type of thing that's going to represent a UNSW student. And we see our good friends, the braces again, which is telling us that, right, everything in here represents the values of the struct. Okay. Then we go inside the struct itself. And these look a lot like what? Variables. Right? We can see that. Type name, type name, type name. And we define what makes a UNSW student in this program. So a UNSW student has an age, which is an integer. A UNSW student has the year that they're in. And in this version, I put a WAM, because of course we keep that about you. Clearly the most important thing we know about you. Now, if I want to create an actual variable of that type struct, this is what we can do. So instead of doing int age or char initial, I do struct and then the name of the struct, UNSW student, and then the name of that actual variable, which in this case I've called it Jake. Any questions on this slide?
You're manually entering every single detail about Jake as integers and doubles.
Up here?
No, down below, where you say struct UNSW student Jake, and then afterwards do you input the values?
Yeah. So the question was like, how do we actually get the values in there? We'll talk about that in a second here. But I want to talk about this idea and this concept so far. Is there any questions so far? No? We're all following so far? Okay, good, great. All right. So really, it's a simple idea. I want a single identifier, like Jake in this case. And every time I have that value Jake, I know that I get, in this case, I get three things: an int age, an int year number, and a double WAM. But the value is that we have a single identifier for all of those things. So it's much easier to use. And I can, going back to answer your question, I can access all of those sub-variables that we typically call fields. All right, why don't we jump to write this so far? All right. So like always, we start our little program like this. I'm going to give everyone a second to catch up on that because I also want to bring up the lecture chat. I realize I don't have it. Oops, spoilers. Hmm.
What do by hard and fast? Okay, all right, I'm back.
Oh,
Oh
no!
no,
That wasn't a
Why didn't you tell me?
Are you serious?
Cheaters!
That's
crazy.
I've lost so much respect. Not
Not
a
a
single
single
person
person
said
said
anything.
anything.
Not even the admin, the tutors.
Were the answers there?
Yeah.
Audio's gone funny, they're saying. Mike is in the toilet. Hello? Testing. Audio jump scare. Is it fixed? Camera audio is on. The audio is echoing.
Echo? Yes? Fixed? Hello? Just remove the mic? What do you mean? What mic? Hello? It's fixed? Fine now. Okay. Better. All right. That was just a distraction over what you did to me with that Kahoot. Anyway, here's our placeholder code here. Oh my God. Let's define a struct together. First thing we need to know is where do we actually define a struct? Where in the program? Now, structs, because they're data types, they're not specific to functions. They're specific to programs. So knowing that, where do you think it would live? Give me a line number. 2. Exactly right. Fantastic. Yeah. It's part of the program, not the function. Right. What did we say the syntax is for creating a struct? Struct. Amazing. Brightest minds of this nation. What comes next? The name, yeah, okay, the name of the struct. So, did we want to do the student example, or do you want a different example? I did the whole Pokemon thing. Who said that, by the way? The whole Pokemon thing started because as my example for struct, I did Pokemon, and I got some awful lecture feedback that was like, we're not kids. I was like, oh my God, all right. So I'm not doing Pokemon ever again. That's somehow worse, but the student yelled at Digimon, which actually is quite funny. Let's not do that. Let's just do UNSW student again. What? I can't win with you guys. Oh wait, you guys all play that. What's that game? Genshin. All right. Is that right? Is that what you call it? A drop? Yeah, but I'm not going to type it too long. Not Genshin. What? Oh my God, we hate it. I don't understand. I thought we like it. All right, I'll do Pokemon. But if I get a single piece of feedback on the form about this, like, oh, it's not relatable anymore. I don't know what I'm going to do. All right, let's have a look back here. We need our curly braces to define what's part of our struct. And what information is part of a Pokemon? It's health points. What data type would health points be? Yeah, I think that's right. What else? Attack. God, we love Pokemon. Let's call that a double, just to have something different. Do they have a stamina? Yeah, let's do speed. No, yeah, that's better. That's better. That's better. That's all right. That's enough for now. That's enough for now. We can't do names yet. That's spoilers. We haven't gotten up to. We can't do type yet either. Well, you could do a character for type maybe, but let's leave it here for now. You get the idea. There's lots of information. I'm gonna get like, I don't know if this is like useful or not, but I get like philosophical often sometimes when I talk about programming. It's just like because I think about it so much. But this is actually, it's a useful thing to be able to do in code, create structs. But it is what makes humans very useful creatures. We do this all the time. We abstract. If I think about like you as a human being, I don't think like height, you know, weight, this, that, blah, blah, blah. I think that's just the person's name. I abstract it all away in an entity. Do you know what I mean? We can't think about every single detail all the time. Like a Pokemon, if I see a Pokemon in the TV show or whatever, I don't think all the different individual properties that make up that Pokemon. I think, oh, that's Charizard or whatever. And so doing this in code is also really important because programs get absolutely massive, like incomprehensibly large. Like Google's source code is incomprehensibly large. You can't understand it all. We need to simplify things sometimes. And structs are one of the first ways in which we can simplify things or abstract things away. They're super, super important. All right, so we got some information, we got some data, right? C, if we think about it in another way as well, C doesn't know what the hell a Pokemon is, right? But it does know what an integer is, what a double is, and what a double is. So now it's learning, or we're telling it, here's how I want you to store the information related to a Pokemon. All right. Someone said, fun fact, Google source code is 2 billion lines of code. Amazing. All right. I want you to look at this thing I've got down here. This is critically important, absolutely critically important. There's no values here, right? Do we see that? Guys? There's no values here. Another way of saying this is, which Pokemon is this? Could be any Pokemon. It's not an instance of a Pokemon. We are defining what a Pokemon is. There's another a big asterisk there. When I run this block of code, how much memory is allocated? So you would say the size of an int multiplied by plus the size of a double plus the size of a double? Or maybe struct has some information? Anyone else have an idea? Okay, the answer is 0. There is no memory allocated. There is no Pokemon. We're just describing what a Pokemon will look like when we have one. Do you understand? There's no memory allocation here.
So it's like annotation. So it's similar to annotation.
I don't know what you mean by annotation, but in the spirit of collegiality, I'm just going to say yes. It's describing. Is that what you sort of meant?
It's like double slash.
Oh, it's not a comment. There's things happen here when this runs, but it's not a memory allocation. Because there's no Pokemon yet. There's nothing to store. What hit points would I put in the variable? I don't know. I might want 50 Pokemon in the future. We're just describing what it will look like. All right. We are only defining the struct. We're not creating one yet. So how do we, and we already spoke about how we create one. We create one in main or in our program itself, and we use struct and then the type, and then the name. And when this line runs here, that's when we get what the student in the rage hat over there said. That's when we get an int and a double on that line. Surprised anyone knows what rage is anymore. So if I want to create Charizard right now, what do I type? Who said Pokemon? You're missing something. Struct. I need to say I want the Pokemon struct. That's the type right there. That's the type. And the name is whatever I decide, and I want Charizard. Create a struct Pokemon. This line creates the memory for an int double. All right, not lines 3 to 7. You can capitalize the struct name. I actually can't remember the style guide. In the style guide, it tells you how you should capitalize structs. I think I do have the capitalization a bit off here, but it will work either way. Any other questions online? Oh, I think I'm missing something here. I think there needs to be a semicolon here. All right, should we run this program? Check that there's no compiler errors. Okay, we do have an error here. Oh, it's unused variable. Yeah, that's a warning, it's fine. It's just saying you've created this thing, but you've not done anything with it. And that runs no problem. We haven't spoken about assigning values yet. We'll do that after the break. Say that louder. Oh, that's a cool question. So the question was, can you define a struct like what we have here on lines 37 inside of a function? Do we want to do a guess? Who thinks it'll work? It's a guess, just guess. Okay. I want everyone's hand to go up at one of the guesses. Like it kills me when I'm like, yes or no, and like 10 people put their hand up. So who thinks that I can define a struct inside of main, let's say? It's just a guess. There's nothing that's going to happen to you. Who thinks it won't work because Jake the Oracle told me it lives outside of main? And who thinks other? Right? So now, if you didn't put your hand up, I'm going to like drop you out of the course. No. I actually don't quite remember. I think it will define it. And when you do something like this, it only exists. You can only sort of use it inside of that function. Yeah, that is the same warning as before. Maybe if I just do like, will that work? Just to get rid of that warning. No. Let's just do like printf. I mean, this will be a different error. Yeah, okay, never mind. Oh my god, I cannot wait until I get... All right, ignore all of that. Yeah, so that does work. Now, there's a slight difference as to what's going on here. This isn't too important for us, but so this works. We're defining what that struct will look like. However, we would only be able to create Pokemon structs inside of main. Now, so far, we only have main. In the future, we'll have other functions. And we want to be able to understand the structs in all of the functions. By creating it here, we would only be able to understand it within main. So it is valid. There's cases where you might actually want to do that. Oh no. but we always define our structs globally. Online, any questions? Seriously, is everyone here a programmer? What? No, not at all. Blah, blah, blah. It's like declaring another type outside of a function versus inside. That's absolutely right. Actually, C doesn't have, oh no, that's Brianna. I took a bit of Python in high school. What? I mean, I would say everyone here is a programmer by virtue of taking COMP1511. That's a beautiful answer. How poetic. I agree, Brianna. You can consider yourself a programmer already. If you've written a program, you're a programmer, and you all wrote Hello World, right? So we have a question here. Hold on, guys, let's be quiet so I can hear the question. Yeah, we're defining the type, a new type called Pokemon. We never declare an int, right? Do you mean if I do like this? That's not declaring an int. It's creating a new variable of the type int. And this is creating a new variable of the type struct Pokemon. Do you see the difference? If I did like struct int, right, there would probably be some problem. I actually don't know what that would do. Maybe it would let me do it. I'm curious now. Yeah, some error that I don't understand there. Actually, why don't we use our AI explainer there? Yeah, look at that. I mean, there you go. So it's saying int is a reserved keyword in C, so we're not allowed to create something called an int.
If the line struct Pokemon Charizard creates the memory for any double, where is the actual memory stored for struct itself? In fact, that struct Pokemon has double.
What a fantastic... You've asked such a cool question. I don't think you quite know how cool it is. So the question was, if this doesn't create any memory, that's what you said, but this does create the memory, how does it know... How did it know what int double and double were, right? Is sort of what you're asking. If it wasn't stored, how can I later go back and realize what I need to know? That's a fantastic question. Because it's true. I promise you, if you inspect the memory of the program, it did not store the space for an int and a double here. Okay, I'm actually going to bring up it might not have been in this lecture. No, it might have been in, oh no, maybe it was Monday's lecture. Oh, in fact, I'll just bring the PDF up. Does anyone remember which slide I had the graphic of the memory? 1.2. Okay, that looks awful. Okay, do you remember this slide? Oh yeah, and I drew it on the board, but okay. When we create create a program, we get access to the stack and the heap, which is in memory. But there is this thing here called code. When we write a program and run it, the source code, the program's code, actually does get copied into the code area of memory. It's actually the reason that if you run a program, in fact, I can do it right now, ready? This is really cool. I mean, I think this is cool. Let's do, you might disagree. While true, so this program's never going to end now, right? Yep, thank you. This program's never going to end, right? Because we're looping forever. I'm going to make a new terminal, and I'm going to delete that program file. And if we go back, it still runs. The reason this is possible, right now, if I cancel this and then run it again, it's not going to run. The program's gone. The reason this is possible is when we run a program, we actually copy the machine code of the program into a special pocket of memory that we programmers can't really interact with, that I'm aware of at least, called the code block. And inside the code block was this definition, because it's in the code. So it didn't need the memory of an int to double a double. It just needed the memory required to store that piece of code. We've gone really off topic here, by the way. Do you want to do a quick lecture break? You can ask more questions at the front. I actually want to run and grab a coffee this time. And then we'll come back, Kahoot, and finish structs. That was a really cool question, though. Sorry?
Stupid thing happens. Basically, when you go to capture this screen, we've got it on this view right now, and we're only capturing this much, which means the resolution is not like crisp.
Oh, but shouldn't that have been?
Well, the problem is
your preview appears when we go full screen.
so
It's one display.
so I'll just
Say that again?
hold on. Let me go to a.
All right, we live? All right, awesome. All right, Kahoot time. I feel like Steve Jobs when the iPhone 4 got leaked. Do you remember? No, you're probably all too young. Some guy left his iPhone. He worked at Apple and he left the iPhone 4 at a bar, and then they leaked it to a journalist. And it was when like Apple was super protective of like all that stuff, and Steve Jobs went mental. Anyway, this is what I feel like now that you've seen the Kahoot questions. Yeah, but still, they kind of Googled it. You know, the tryhards. I don't know if he got fired. Let's Google it after the Kahoot. I think, and it was even like, so it was an iPhone 4 in a special case that made it look like an iPhone 3GS, but someone picked it up. Sorry? Oh, sorry. Alrighty. Yeast and chic, what are you confused about? Oh, there's a good question while everyone's joining from Mason. Does the struct itself use any more memory than the variables inside of it? The answer is no. So structs in C, in fact, C itself is just a very efficient language. No extra memory is required to store a struct. Bots, robot invasion. All right. A few more seconds. Are we ready to go? Ready to go? Ready to go? All right. Let's go. iPhone 4 was an era. I agree. All right. Why do we use if statements? Starting off with a softball. Oh God, the silence. Yeah, to loop. Yeah, click orange, everyone. I love red. I love the red one. All right, very good. To execute different blocks of code for different conditions. Exactly right. Straightforward there. True or false? If there are 4 penguins, pipe, they are the same height. So look at the image. Think about what that pipe means. What's the answer? What did you do? What did you think? Yeah. True. What do you think? True or false? 20 seconds more. Jeez. Sleep. But what? I don't want to skip it, do I? Will that end the timer? But and I can still see the answers? Okay, all right. Oh no, guys, 50-50. That's not good. All right. What's the name of this operator? Or. So, with an or statement, either of the conditions has to be true, only one of them. So are there 4 penguins? True. Are they the same height? So true or false is true. Yeah? Yes? Well, then you should have got it right. All right. Well, we've sort of buried the lead with this one. Look at, oh my goodness. Look at the answers fly in. All right. I'm going to skip it once we get to like a bit more. Khalid thinks we've got bots. How many students were in the Kahoot? 280? You know, if everyone just clicked an answer, it would end. Stragglers. I'm going to skip it now. All right, very good. With an and statement, they both need to be true. Clearly, you picked that up. All right, I didn't know I could skip. That makes life a lot easier. All right, let's get a bit trickier. If 7 is less than 15 and 8 is greater than or equal to 15, is that going to be true or false? For some reason, you only had... Why is it counting down in 2-second increments? Weird. Skip. False. All right. 7 is less than 15, but 8 is not greater than or equal to 15. So true and false is false. Oh, nice job, chef. Here's another one. Come on, this one should be easy now. Yeah, true. So either of the 2 sides of the condition needs to be true. Where did you get those from? The barbecue? You know, I don't want to alarm you, but I saw those sausages sitting out in the corridor for like 4 hours this morning, not refrigerated. All right, here's a trickier one. This is going to screw with you guys. All right. All right, let's break this down quickly, right? So, all right, here's how I would tackle something like this, because even if I look at this, I can't instantly get the solution. We need to interpret it. All right, we've got brackets, which means everything in the brackets runs first. So what's in the brackets? We have 5 is less than 10 or 6 is less than 13. So is 5 less than 10? That's true. So I actually don't even need to finish the rest of it because true or something is true. So we have everything in the brackets is true. Then everything in the brackets is false is knotted. I don't know if that's the right word. So true would become false or false would become true. So true becomes false, so the answer is false. Does that answer, if you got it wrong, does that explain it? Very good. All right, last question, true or false? All right, very good. Why is A less than Z or Z? right? Oh God. A was it lowercase? Yeah, lowercase. A is 97. Z is 122. So that's really doing is 97 less than 122, which is obviously true. All right, chef number 3 is chef in the room. Your chef? Did you win last time? No. Well done. Medal? Online medal? And Tom VB. What? How are there 2 of you? It's you. All right. Well, congratulations. Good job. Oh no, I forgot the Pokemon cards again. You can come to my office after this. Why did that reset the slide? All right, this is where we were, I think. All right, we good to go? Oh, that's the wrong thing. That's the wrong thing. Where is the right thing? I've lost it. Whatever, I'll be fine. All right, someone said cooking like a chef. I agree. Good job. All right, so this is defining our structs. And I know the burning question on everyone's mind is, how do I get the sausage sizzle? No. What is it? How do we read the values? If there's a bunch of values in here, in a simple, easy to use variable, how do I actually read them? How do I access the actual data? And the answer is really kind of simple, cool, and neat, and it's this dot operator. So here's another example of a commonly used struct called a coordinate struct. So a coordinate struct is how we represent 2D sort of position, a grid. So X and Y coordinates. The name of the struct is what? Coordinate. And the 2 fields are X and Y, which are integers. And all we need to do is create an instance of our struct, which is what we're doing here. And then we can just say location.x, that is that integer x. Location.y, that is our integer y. It's that simple. But the cool thing is that they're both contained within that single identifier location, LOC. All right, so if we jump back to this example, I've got this Charizard Pokemon, which means when I create a Pokemon, I get which 3 pieces of memory? I got what you meant, int double, right? HP, attack, and speed. So if I want to initialize Charizard's HP, what do I type here? Charizard, then what? Dot HP. And then now it's just a normal integer. So what is Charizard's HP? Who said 5,000? It's 78. Well, what's this? What's 360? Anyway, it doesn't matter. Right? Now we initialize that piece of memory. I'm going to come to the whiteboard here. Here's how I want you to think about it. Or rather, here's how I think about it. So we get to line 13, and we get struct Pokemon. Can you read this online? So we get this Charizard Pokemon. So in my memory, right, if I create an integer, you probably can't read that, int x, I get this thing called x, which gets a box for, an integer. When I create a Charizard, which is a Pokemon, I get Charizard, and I get a bigger box with HP, was it speed? Well, what else did I get? Attack. Right? So on line 15, right? On line 15, I'm looking up the Charizard struct, which is here. I'm accessing the HP field, which is here. And I'm putting 78 in memory. Let's just do whatever. I think whoops. He's pretty fast, I think. All right. So that is changing our memory, right? But it's all grouped into a single variable. If I want to do things with these pieces of data, right, I use them in the exact same way you would expect. So if I want to print Charizard HP is, what flag would I put here? Y%D? Because it's an integer. Then what value would I pass into printf? So I can't just do HP because that's not a variable. I can't just do Charizard because that's not an int. Charizard.HP. That is my integer now. And that gets printed out.
So what's the usefulness of doing this as opposed to just saying,
yeah, okay. So that's a good question. So the question was, what's the usefulness for creating a Charizard struct and grouping up the variables in it, rather than just having, I could have a variable called Charizard HP, Charizard underscore attack, Charizard speed. All right, so it is a good question. The simple answer is that the usefulness will become clear in a future lecture. But I'll skip ahead a bit. Sometimes we need to, okay, let's say I want to have a way to print a Pokemon to the terminal. So I want to print out its HP, its attack, its speed, its name. I can actually teach C how to print out a Pokemon. And to do that, it needs to know about the struct. So there's things that we need to do, otherwise it would be repetitious in code. Repetitive, not repetitious. All right. Yeah, thank you for repeating my thing. Any questions on this struct so far? This is where we're leaving structs today. Now, you will be using, in the final exam, you will have a lot of questions on structs. They aren't going anywhere. So it's important you understand them deeply. Don't let them scare you. This is my #1 advice for structs. They're not that tricky. They're as straightforward as they seem. It's just a way to group multiple things together.
if I wanted to create an attack, I'll put ls, but then it's maybe I don't want to see that many decimals.
Well, but that's so. The question is, how do I not print out 50.3000000? Wasn't that covered in the lab? Yeah. Have you done the lab? Maybe finish the lab and then. So that you can pass how many values you want printed to LF. We can quickly do it. Can someone remind me how to do it? Oh, let's do 2. Cool. And I can do the same for attack or whatever. All right, any other questions on structs? Oh, that's a cool question. Did everyone hear that? So the question was, can you have nested structs? And the answer is yes. We won't do it just yet, but you can. And you just do, x.y.z. Okay, question, if the new data type we made called Pokemon is called a struct, what is the technical term for a particular entry that is a struct, i.e. Charizard? What type of thing is that? I think what you're asking is, what is Charizard here? Is that right? Zamax? Or Brianna, is that what you interpreted as well? Oh, Zamax's question? Yes, okay. So, okay, so the question is it's a good question. Let's just run through and annotate everything here. So this is a struct declaration or definition. We're defining a new struct. It's named Pokemon. So it's a struct definition. This creates an instance of a struct. So I would call this, we would just call them both structs in reality. This is the Charizard Pokemon struct. So it's an instance of a Pokemon struct named Charizard. .hp, .attack, and .speed, we could call these fields. Hopefully that answers your question. All right. About 10-15 minutes left, and we've got one more topic to introduce. It's also part of custom data types. So it's a different type of custom data type we can create. Let's keep the noise down, please, for the online viewers as well, especially. Guys? All right. So a new type of custom data type. This was the struct custom data type. This is called the enumeration or the enum custom data type. So enumerations. What's an enumeration? Does anyone know what the English definition of an enumeration is? A count? That's pretty much correct, yeah. So if you enumerate over something, you're counting through them. All right. So the example on my slide here is, imagine I want to store the days of the week. How would you do that right now in C? So if I asked you, lab, new lab for this week, go and store the days of the week in a variable. What data type would you use? Character? Now, but what would you do for Saturday versus Sunday? You're in a bit of trouble there. Strings we haven't covered yet. Nice try. Someone said an int. Int's the closest thing we have. So you would have to say, well, 0 is Monday, 1 is Tuesday, 2 is Wednesday. You get the idea. So that's what you could do, right? That is, in fact, what you would do. There's a little problem with that. So very quickly, what is the integer for Saturday? Quick. Okay, well, 6. That assumes you start on Monday or Sunday, right? There's a chance for confusion here, right? So is there a better way to store a set of possible values as a data type. So here are some of those options that we spoke about. I could use a character, but that's confusing for Saturday and Sunday. That's not a good idea. I could use an int. That is a better idea. I could use hash defines. I could use constants. That's probably the best idea of all these three. No one thought of that. So I could hash define Monday as 1, hash define Monday as 2. But the problem with these approaches is that I've got to remember what 1 is, what 2 is, and so on and so forth. Easy for the days of the week, or easier for days of the week. But another really good example of an enumeration would be a Pokemon's type. You know, flying, fire, water. There's no logic for what would 1 be. What would fire be? 3? 4? There's no idea. It's just a random set of values. And if we use the hash defines, we have another problem. The hash defines don't build in a limit. So in theory, I could accidentally assign 8 for the day of the week. So we have this solution called Enums. They allow us to define a set of possible values, a range of values. And this second point is really the value here. It's a more meaningful name to a state. So let's look at the syntax. So just like when I create structs, we use the struct keyword. When I create an enum, I use the enum keyword. So I say I want a new enum. I give it the name of my enum, my set of braces, and I comma-separated list of the possible values. So for the days of the week, I can say my weekdays enum can be either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. That's it.
Do you have to have a space in that set at the start?
No, you don't need a space here. No, that would work either way. Yep.
Can this differentiate between starting on Sunday or Monday?
Can this differentiate between starting on Sunday or Monday? We'll talk about it in a second, but yes, you would just put Sunday first. So you'd go Sunday, Monday, Tuesday, Wednesday, Thursday. Yeah. Are we all clear on the concept here? Why we want this? Is it clear? Yes? Online? Okay, online they're having their own private chat apparently. So how do we use them? So just like structs, we define the enum outside of main, outside of the functions, and then we can use them inside of main. So, and when we create an enum, we do the exact same thing we do with structs, right? You see that? Struct, type, and then the name of my struct. So let's jump to our program here. And let's create an enum, and it's kind of, Pokemon is kind of a nice example because the type is the perfect use case for an enum, the type of the Pokemon. If you're not familiar with Pokemon, that's completely fine. Pokemon are these creatures, they got some stats about them, and every Pokemon has a different sort of elemental type, let's say. So some of them fly, some of them use fire, water, whatever. All right, so if I'm going to create an enum, what do I type? Let's call the type, or actually, no, not type. Let's call it I have my set of braces, and then I can just list the different types. So there's flying, water, fire, I don't know, there's dragon. Yeah, grass, yeah, you get the idea. There's more than this, but you get the idea. Okay, the question is, good question, does it matter if we define an enum first or a struct first? The answer is no. Well, actually the answer could be maybe, but for now it doesn't matter. Let's leave it like this for now. I'll explain a bit more about that in a second. So I've defined now this new type, this new data type called elemental type. Let's keep the noise down. Only 10 more minutes, everyone, please. And I've decided here are the possible values this enum type could be. So that means in main, I can create an elemental type. So what's the data type here? Enum elemental type, exactly. And I can, no, I need to give it a name, you know, my type. And I can assign it a type, like flying. Yeah. And this line here shows why enums are cool, right? Because if I ask, you know, you right there, line 14, what type did I assign? What value did I assign? Sorry. Flying. You just read it. It's so simple. If these were integers, it would be like 7, and you would have to look at the thing and count it, and it would be just a bit more confusing. When we write code, it's both for the machine and it's for other programmers and for ourselves. We want it to be really glanceable and readable.
The variable is technically an int.
We'll talk about what it technically is under the hood later. Do you mean here? What do you mean declare it before? Because here I'm declaring it on the same line. I'm declaring it here. So another way I could do this is like this. Just like any variable. Any other questions? Online? Yeah, Mason said, so it's kind of like a little hash define, and the answer is yes. Yep. Ah, okay. Well, good point. So the question this student asks is, what if we type something that's not a potential value of the enum? So first of all, let's compile this and check that it all works. Because there is possible that I put no, that's just a warning because we're not using it, so that's okay. So you can see here that it's learned that flying is a part of this enum. It knows that it's a valid keyword here. I haven't defined, what's another type? Ground. I haven't defined ground here, right? So is this going to work? No, because the compiler doesn't know what ground is. It's not part of our custom data type at the moment. So it's going to get confused. What I need to do then is define ground as a potential value. And at that point, it'll just compile with the same warning as before.
How big a custom data type? How much information can they store?
The question was, how big are custom data types? How much information can they store and how much memory do they take up? Let me talk a little bit more and then remind me to come back to answering that. Yeah, with enums, life gets easier. That's what one of the online participants said, and I think that's absolutely true. All right. Under the hood. Under the hood, just like characters, enums are actually just integers. So the benefit we get over the integer is that it defines the range for us, but really they are just integers. And so because they're integers, we can print them with a %d, and we will get the integer out. And the integer starts at 0. So Monday in this case would be 0, Tuesday is 1, Wednesday is 2. So in theory here, I can put 0 here. And what would that be? Flying, because that's the first set in the enum. Exactly right. Okay, a lot of questions here. Let me see what else I've got here. Why don't you read this slide of notes yourself? Here's the advantages of enums over other approaches. There is a disadvantage to enums compared to hash defines. They use more memory, so therefore they're less efficient. But they make our lives a lot easier. I didn't pay him, I swear. You can absolutely put enums inside of a struct. So the question was, can you put enums inside of a struct? Enums and structs, they're good friends. And that's exactly what we can do here. Pokemons have a type, right? So let's build that as part of our struct. Well, what is the elemental type? It's the enum elemental type. And what's the name of it? Let's just call it the type. Now, a Pokemon, every time I create a Pokemon, has a HP, which is an integer, has an attack, has a speed, and it has a type. Which means now, if I recall, he's flying. I think Charizard is flying type. Whatever, we can't do both yet. So, well, in fact, we could actually. Right, we could do something like that. And now my struct is keeping track of the Pokemon's type as well. And all we've done is put that enum declaration inside of the type. It's really cool. Oh no. The QR code's for some reason broken. Well, actually, I can go to the end of this slide. No, I can't. Wait. No, wait, lecture one didn't have it. What's wrong with this? No, wait. All right. That was Structs. Oh, wait, no one go anywhere. Lock the doors, Brianna. No, don't look at my teams. Okay, do you remember I showed you the research study? We're now giving you money for doing it. An amazing $20 gift card. So please scan the QR code. And you could be the new owner of a $20 gift card too. It's only like 30 minutes of time, and it's on campus. It's not a big ask.
Using our question. So enum is an integer.